Welcome back, deep divers. Today we're taking a trip to Mars, or at least to a tiny piece of it right here on Earth.
That's right, we're talking about Martian meteorites. Specifically, one called Black Beauty that's giving us some incredible clues about the history of water on the red planet.
Okay, so paint a picture for me. I'm holding this piece of Mars. What am I looking at? What's got scientists so excited?
Well, Black Beauty is this really cool breccia, basically a mashup of different Martian rocks. And inside, scientists found a tiny zircon crystal, just a few hundred microns across.
So smaller than a grain of sand.
Much smaller. But don't let its size fool you. This little crystal packs a big punch when it comes to understanding early Mars.
What's so special about it?
This zircon is about 4.45 billion years old, which makes it the oldest evidence of water on Mars that we've ever found.
Wow, that's almost as old as the solar system itself. So you're telling me this tiny crystal is pushing back our understanding of water on Mars by how much?
By a lot. We're talking 150 million years, back to the pre-Noetian period, the very beginning of Mars's geological history.
That's a pretty big shift in our understanding. But I have to ask, how can scientists be so sure this little crystal tells us anything about water?
It's all in the chemistry. You see, when zircons form, they can trap tiny bits of their surrounding environment inside them. And this particular zircon from Black Beauty has specific elements: iron, aluminum, and sodium, in a very particular pattern.
So like a chemical fingerprint that tells us it formed in water.
Exactly. That pattern is a clear sign that this zircon crystallized in the presence of hot water, likely deep underground.
Wow, so even in its earliest days, Mars was a hot and watery place.
It seems so, and this discovery really supports the idea that early Mars had what are called hydrothermal systems.
Hydrothermal systems. Remind me what those are again.
Think geysers and hot springs, places where water interacts with hot rock below the surface. We see them on Earth today, and they're thought to have played a crucial role in the origin of life on our planet.
So if Mars had hydrothermal systems billions of years ago, could life have existed there too?
That's a huge question, and while we can't say for sure, it's certainly a tantalizing possibility.
It definitely is. But even beyond the question of life, this discovery is changing what we thought we knew about early Mars.
Absolutely. It's painting a picture of a planet that was much more dynamic and potentially habitable than we once believed. And who knows what other secrets this little piece of Mars might hold.
We'll have to keep digging deeper, and that's exactly what we'll do after the break. So we've been talking about this evidence for a wet early Mars, but as we all know, the Mars we see today is pretty much a desert. So what happened to all that water?
Well, it's the question, isn't it? It's a question that's been bugging scientists for a really long time, and there are a few main theories that are being explored. And it's very possible that a combination of factors led to Mars drying up.
So it's not a simple answer. I guess that's science for you. Let's unpack those theories. What are some of the leading ideas about where all that Martian water went?
One possibility is that a lot of that water was lost to space.
Lost to space? Wait, how does a planet just lose all its water like that?
Well, think about it this way. Mars has a much weaker gravitational pull than Earth, and its atmosphere is much thinner. That means that it's easier for things to escape, including water molecules.
Okay, I see. But how do they actually escape? Is it like the water just evaporates and then floats off into space?
It's a bit more complicated than simple evaporation. It involves a process called atmospheric escape, where solar wind and radiation from the sun are constantly bombarding the upper layers of the Martian atmosphere.
So the sun is basically stripping away Mars's atmosphere.
Exactly. And when those high-energy particles from the sun hit water molecules in the atmosphere, they can break them apart into their components, hydrogen and oxygen. The lighter hydrogen can then escape Mars's gravity more easily and drift off into space.
Wow, so it's like the sun is slowly stealing Mars water bit by bit. That's wild.
Is there any actual evidence to support this theory? There is. Satellites orbiting Mars have actually detected traces of water vapor high in the Martian atmosphere, so that suggests that water is still escaping even today, although probably at a much slower rate than billions of years ago.
So Mars is still leaking water even now. That's incredible to think about. But okay, let's move on to another theory. What about the idea that some of Mars' water is actually hidden underground?
Yeah, that's right. That's another major theory scientists are investigating. The idea is that a significant portion of Mars' water could be trapped beneath the surface, either as ice or potentially even as liquid water in underground reservoirs.
So like a giant Martian aquifer.
Exactly. We know for sure that Mars has polar ice caps, but there's also evidence to suggest that there could be layers of ice beneath the surface at lower latitudes as well. There have been some fascinating hints from radar data and even observations of surface features that point to this possibility.
That would be an amazing discovery. Imagine vast reserves of water hidden beneath the surface of Mars. But what about the possibility of life? What would it mean if we found liquid water underground?
Well, as you know, liquid water is considered essential for life as we know it. So finding liquid water on Mars would be a major game changer and would significantly boost the chances of discovering evidence for past or even present-day Martian life.
Okay, so we've got water escaping into space and water potentially trapped underground. Are there any other factors that could have played a role in Mars losing its water?
Yes, there's another important piece of the puzzle. Mars' changing climate. Billions of years ago, Mars was likely warmer and had a thicker atmosphere. But as the planet cooled over time and its atmosphere thinned, the conditions for liquid water at the surface became much less favorable.
So even if the water wasn't lost to space or trapped underground, a lot of it could have simply frozen as Mars got colder.
Exactly. Think about it. As temperatures dropped, any surface water would have frozen. Much of it would have become locked up in permafrost or glaciers, making it inaccessible.
It sounds like the story of water on Mars is incredibly complex, with lots of different forces at play over billions of years.
That's right. It's a multifaceted problem. To fully understand what happened to Mars's water, we need to consider all of these factors together.
It's amazing to think about how all of these theories about Mars's water started with that tiny zircon crystal in the Black Beauty meteorite. It just goes to show how one small discovery can completely change our understanding of a whole planet.
It really is a testament to the power of scientific investigation. And the more we study Mars, the more we realize how much more there is to learn.
Speaking of learning more, we've been focusing a lot on the past. I'm curious about the future. What are scientists doing now to try and solve this mystery of Mars's missing water?
Well, there are a lot of exciting missions and research projects happening right now. For example, NASA's Mars Reconnaissance Orbiter is still orbiting Mars, collecting data about the planet's atmosphere and surface.
And what about rovers on the ground?
Yeah, so the Curiosity and Perseverance rovers are both actively exploring different regions of Mars, taking samples and conducting experiments to learn more about the planet's geology and potential for past life.
It sounds like we're getting closer and closer to understanding the full story of water on Mars. But I have to wonder, what if, somewhere beneath the surface, there's still liquid water flowing today?
Now that's a tantalizing thought, and the search for that subsurface water is definitely one of the most exciting areas of Mars exploration right now. There are even some scientists who believe that if there is liquid water underground, it could potentially harbor life.
Whoa, life on Mars in underground lakes or aquifers. That would be incredible. Okay, so we've covered a lot of ground today. We've talked about how Mars lost its water, the evidence for potential underground water, and the ongoing search for answers. And you mentioned that there are scientists who believe that liquid water underground could potentially support life. That leads me to a question that's been on my mind. What if we do find evidence of life on Mars? What would that mean for humanity?
That's a big question, and one that we'll need to grapple with as we continue our exploration of Mars.
Let's dig into that right after this. Okay, so let's just say, hypothetically, we did find evidence of life on Mars. What would happen next? What would that mean for us here on Earth?
Well, that's when things would get really interesting and also really complex. I mean, confirming the existence of extraterrestrial life, that would be a monumental event. Scientifically and philosophically, I mean, it would change everything.
I can only imagine. It would definitely make us rethink our place in the universe, that's for sure. But from a purely scientific perspective, what would be the next steps?
Well, the first thing we'd have to do is meticulously verify the evidence. We would need multiple independent studies using different methods, different lines of investigation, just to be absolutely sure that we're really looking at signs of life and not some kind of weird geological or chemical process that might look like life but isn't.
So a lot of double-checking and triple-checking to be absolutely positive.
Exactly. I mean, we wouldn't want to jump the gun and announce, hey, we found Martians, and then later have to say, oops, never mind, it was just some rocks.
Right, that would be a bit embarrassing. So, okay, let's say we've done all the checking, and it's confirmed we've found life on Mars. What then?
Well, then the real work begins, right? Then the focus would shift to understanding this Martian life. Is it microbial? Does it resemble life on Earth in any way? What's its evolutionary history? How did it survive? Those are just a few of the questions that would drive research for I mean, probably decades.
It really is mind-boggling to think about. We might have to rewrite all the biology textbooks.
Yeah, I mean, it would force us to rethink everything we thought we knew about the origins and the diversity of life.
And of course, there's the ethical dimension to
Yeah.
consider, right? I mean, what are our responsibilities if there's life on Mars?
Oh, absolutely. That's a huge one. If Mars is inhabited, even if it's just by, microbes, it raises some profound questions about how we explore the planet and how we protect that life.
So we'd need to be really, really careful about contamination.
Exactly. I mean, bringing Earth microbes to Mars, even unintentionally, could have devastating consequences for Martian life. We'd need to develop strict protocols, new technologies to minimize the risk of contamination.
It's so much to consider.
Huh.
This conversation has gone from, wow, water on Mars, to, whoa, the future of humanity
Yeah.
in the space of like an hour.
I know, right? It's really amazing to think how one tiny zircon crystal can spark such huge questions, not just about Mars, but about life itself. It really underscores the power of scientific discovery and the importance of staying curious and asking those big questions.
Absolutely. It's a reminder that we're still just scratching the surface of what's out there, and there's so much more to learn. Well, that's all the time we have for today's deep dive, but the conversation doesn't end here. We want to hear from you, our listeners. What are your thoughts on the possibility of life on Mars? What questions would you want to ask? Head over to our social media pages and let us know. And until next time, keep looking up and keep exploring.